Hi, we're here at the iCar Tech Center to talk about safely approaching hybrid electric vehicles. I'm Bob Jansen, and with me is our resident hybrid technical expert, Jeff Poole.
Thank you, Bob. Pleasure to be here.
We're standing by a Honda CR-Z, which is a hybrid electric vehicle with a high voltage system. But let's start talking about the 12-volt system on this vehicle.
Bob, what we have is a 12-volt system that has a negative battery terminal connected to the core support apron area, creates the common ground in the chassis of the vehicle. The positive connection of the 12-volt battery, as we can see identified by the red protective covering here, branches off with cables that go to power distribution for the control modules, computers, and 12-volt accessories on the vehicle, much like our traditional vehicles.
So Jeff, if I would touch a 12-volt connection and use my other hand to touch a part of the chassis, I would have 12 volts going through my body.
Bob, a small amount of current is flowing through your body right now, but it's such a negligible amount that you can't even feel it.
So what's the relationship, Jeff, between the 12-volt system and the high voltage system?
Bob, to better understand the relationship of the high voltage system versus the 12-volt system, we need to take a look at the components in the back of the vehicle.
So here we are at the back of the vehicle where the high voltage power source, the high voltage battery, is located.
Bob, before we proceed any further, I'm going to put on my high voltage gloves so that we can work safely. We've removed the hardware that holds the cover in place on the battery. This is a procedure that an out-of-physical damage appraiser or estimator would not typically be doing. However, a technician may have to take and remove these components if the vehicle had rear collision damage that required removal of the battery. Once we have the main cover off, we can see that internally there's some additional access covers that we'll have to remove. With the metal cover removed, we can see there's an additional plastic protective cover over the cables that run forward to the motor. The 12-volt system manages all of the computers and control modules on the vehicle. Those computers and control modules then manage the high voltage in the system. The high voltage battery module that we're looking at here is what we call a floating system, meaning all of the high voltage in this system does not tie in with the chassis ground of the vehicle. Rather, the 12-volt system takes and manages all of that high voltage energy, and these cables go forward to the motor with the high voltage.
We've lifted the vehicle so we can see how the high voltage gets from the rear to the front of the vehicle, but that cable that carries that high voltage can also get damaged.
The likelihood of damage to that cable is very slim. However, it is vulnerable in certain collision scenarios, perhaps if the vehicle goes off-road or runs over something in the road. We're taking a closer look at the conduit that houses the high voltage cables that run from the back of the vehicle up to the motor in this particular vehicle. Internally, the cables are well insulated from each other and the conduit, providing protection from damage.
To give us another perspective, we're standing in front of another hybrid vehicle, a Ford Fusion hybrid. Jeff, it looks a little bit more complicated. What are the differences with this one?
Bob, the other vehicle we were looking at was a Honda hybrid, which is a mild hybrid. The motor control module and the high voltage battery were located in the back. On this particular vehicle, it's a full hybrid. The high voltage battery and the 12-volt battery happen to be in the back of this vehicle, but the motor control electronics, the inverter converter unit, is mounted up front. So that's why we see so much more in the way of the orange cables and the components that are mounted under the hood area. We're looking at the inverter converter unit on the Ford Fusion hybrid. The high voltage battery is located in the back. The orange cables are bringing that power forward to this unit. This unit manages the power going down to the motor generators and the transaxle. Of interesting note in this particular case, with the 12-volt battery in the rear, there's actually a 12-volt power access point and a cable that runs in with the orange high voltage cables to the rear of the vehicle.
Jeff, I notice, unlike on the CR-Z, this one has a separate orange cable that runs along the front here. What's that for?
That particular cable runs over to the electric air conditioning compressor pump. The CR-Z had a mechanical pump with a belt drive, so no need for the cable.
Jeff, my final question to you is, these hybrid vehicles have a lot of safety backup systems. They're relatively safe, but when it gets in a collision, it's an entirely different situation. So how does an appraiser approach a damaged hybrid or electric vehicle?
Well, Bob, the best thing to do is a visual inspection, see if there's any compromise. And you really don't want to take a risk or a chance. If there's something that you can't see that potentially is damaged, you don't want to reach in barehanded and start to pull on things and move things around until you're absolutely sure that the system has been de-energized. Electricity is not going to give you a warning, and you may not get a second chance.